Cool. Okay, great. Thank you very much, Uber, for having us here. I say us because there's actually a bunch of Mapbox people here. But yeah, it's really exciting to talk a little bit about Mapbox and about some of the cool things we're doing with telemetry data on the GPS side as well as the visual side. So again, my name is Tory. I'm a product manager at Mapbox for the Vision SDK, but I'll be talking a lot about some of our heritage working with open source as well as working with GPS probes as we sort of launch forward into looking more and more at some of the autonomous use cases and the ability to build really rich maps with live data. So just in case you don't know much about Mapbox, we actually don't have an app in the App Store, but we do have over 500 million MAUs now. The way we work is we build APIs and SDKs, most of which are actually open source, that developers use to build all sorts of really cool applications for everything from navigation to maps to search to data. We've actually worked a lot with a lot of the other companies that are here tonight building all sorts of cool applications. So we don't have the same type of end user that a lot of our customers have, but we do have over 1 million developers that use our APIs and SDKs to build really great stuff. It's actually a really fun business to be in because our customers are developers, and we love developers. We also, one really cool thing in terms of data, we collect over 300 million miles every single day of telemetry data. So I'll talk a lot about what we do with that and how we sort of turn that into really rich data sets that we can use to deliver all sorts of things, everything from traffic to ETAs to directions and so forth. We work with a whole bunch of different companies today, everything from the social media space to the largest drone company in the world to the weather company. We also work a lot with governments, with NGOs. But obviously, we're here tonight because we're also really excited about mobility and within that, autonomous vehicles. One of our coolest projects from the past couple of years is actually the work we did with Uber on Kepler GL. Is this cool? It is animating. Awesome. And I'm not going to go too much into Kepler because there's probably a lot of people here that know much more about it than I do. But we really love the ability to take data from a plurality of different sources and turn it into really cool visualizations. So I'll be talking a lot about autonomous vehicles, obviously, but also about how we can visualize a lot of those core data sets to make them really interesting. So with Mapbox, it all really starts with the map. So anytime you're looking at a map from Mapbox, which is not unique to us, but this is definitely the fundamental way that we think about the world, it's all about layers. So we have over 100 different layers that make up any map. No map is going to have all 100 of those or all 150 of those like visible at the same time, but it's really helpful in thinking structurally about how we think about data. Because there's a lot of different kinds of data in the world, and when you're building a map with us or with a lot of other people, you're really thinking usually about a couple different use cases for that map. So we have obviously a satellite layer, there's a weather layer, we have things like terrain, but as you start to make your way up the list, there's more and more granular things once we get down to like POIs, real-time traffic, and especially obviously with HD map and road DNA and 3D data where things start to get really interesting. So one really practical example of that that we announced a little bit less than a year ago is some work we did with Mobileye around, I'm sure many people here are familiar with the Mobileye Roadbook, where they're taking data collected with their really powerful ADAS distributed set of cameras and turning that into electronic horizon product. So what they're doing here is they're using our tiling service to serve this data to the vehicle. So as you're driving down the highway, you are able to pull in information about road boundaries, lane boundaries, the center lines of the road, and then all these white things that are popping up here. These circles are sort of little landmarks that are stored. These are mostly things like lampposts or signs, things of that nature. And what this does is it gives you somewhat of a prior for something like an autonomous vehicle, but also on the more near term, things like adaptive cruise control and highway assist can use this really useful information about like where shoulders exist, what the road curvatures are to help you plan a more smooth and safe driving experience. So this is like super on the application side, but what I'm going to do now is zoom really far in and talk about something much more specific. So we'll get super fundamental and talk about a probe point. So we collect about 9 billion of these a day. And with every probe that we collect, we just collect a couple very basic pieces of information. So we have a timestamp, latitude, a longitude, and an elevation. And then we have some notion of how accurate that is based on how noisy the sensor was. So notably here, we're not collecting the user ID, we're not collecting the device ID, We can make inferences about where this data point came from based on the quality of this data, but it's really important for privacy purposes that I'll touch about later that we don't really collect anything that we don't absolutely need to deliver things like traffic and ETAs. So just with a single probe point, there's a lot of cool stuff we can do, obviously. We can tell you about POIs that are nearby, but things really start to get interesting once we start moving around, because then we can start to think more about things like navigation, which is just maps in motion. And when we have lots of people moving around, then we have traffic, and then we really start having fun. So I'll talk a little bit about how we play with traffic and how that forms some of the basis of the vision work that we're doing today. So this, I'm sure most people here recognize, is San Francisco. But this is like the data that we get like right out off the server, basically. And you can see here, you can definitely make out the street, the road network in San Francisco, but it's super noisy. And you can see lots of straight lines that seem to dart all the way across the map in ways that clearly do not line up with how you would actually get around. I'm sure most people here are pretty familiar with phenomena like multipath, which is obviously a major challenge. You just need 3 satellites to figure out where you are. But if you're driving down Market Street, chances are those signals are bouncing off a lot of things that are going to throw off your estimate of where you are. So we have a couple ways that we deal with this when we're ingesting all of this data to get a little bit of really useful signal out of a whole bunch of noise. And it starts with making a couple assumptions about the nature of that noise. So if you're standing right on the X, for example, in the middle of a field, chances are most of those probe estimate points, if you're just standing still with a device, are not going to line up on the X, but they probably will mostly fall within like the 10-meter radius. And the distribution is going to look something like this. So if we use that information along with having billions and billions of probe points, we've done a lot of work on the analytics side to try to figure out the best way to turn all that noise into some signal. And then we start to get something that looks closer to this. So this is actually like, these are really cool, pretty visualizations, but this is actually all real data, which is neat. And what you see when you look at this is much more clearly you can make out the street structure of San Francisco for one thing, but you can also notice that a few things don't get removed by the filtering. And those things are actually pretty interesting and correspond to a lot of real world things. Like you can make out, for example, where people would be standing in Civic Center, and you can actually make out the walking pathways where everyone's taking selfies in front of Alamo Square. So that's super neat. Here is another way of looking at that same data. This is all traffic data where we've sorted the probe points. So these are all the individual probe points, but we have a spectrum of different colors. So the faster moving that trace was at that time, the more bright and green we made it. And this is really neat because you can actually kind of make out that there's 5 lanes here. And you can see that there are HOV lanes that are being used to go super fast. Or these could just be, I think this is actually 101. So yeah, these are HOV lanes. And then in the darker reds, you can either see down here, we've either got cyclists or slow moving traffic or pedestrian traffic on this frontage road. And then if we do some more filtering even on that level of data, this is a super cool thing that we're doing where we're visualizing this in a slightly different way, but we're turning all of those probe points into what we call driven center lines. So the way we're visualizing the data here is as each, when we collect all these traces, we're reconciling these down to specific center lines. And we, based on the color and the average speed driven at that point, we're making assessments of how fast are people actually driving on things like the exits or the entrance ramps, excuse me. And then you can also see even where lane changes typically occur. And when you do this kind of sampling on this quantity of data, we still run into some cases where it seems like it doesn't look quite right. There's no way to get this data perfect, but there's some really cool insights that we can derive from looking at data like this. For example, in many cases, we find out if there's road construction or if there is a new road that's been built before the satellite imagery has been updated. Because we're collecting this probe data constantly. This is a cool example of where we've taken that data and we can actually tell without knowing where this picture is that it's a right side drive country because we've taken another derivative and now we're looking at acceleration and deceleration profiles. So since we see all the deceleration happening pulling up on this side, we know this is a right-hand drive. This is an airport where we've actually taken all the different profiles, and for any trip that originates at this location, we are using warm colors, and for any trip that terminates at this destination or at this location, we're using cooler colors. And you can actually see some pretty cool patterns here. For example, you can see that people that are arriving at the airport are driving around and struggling to find parking, whereas people that are leaving the airport are mostly paying for parking, looks like right there. So there's some pretty cool things that we can learn about how people as a large group behave. I think this is the last example. This looks a little bit weird, but this is actually the sunset. And what we've done here is we've clipped all of our telemetry to only look at intersections. And for every single intersection, what we do is we look and see where most of the vehicle is coming from. And if a vehicle is coming from, say, right here, where is that vehicle leaving? And like what percentage of people are going which ways at which times? And if we do that, we're actually able to extract things like turn restrictions. So without having to walk out there and read a sign, we can actually tell that if 99% of people don't turn left somewhere, you're probably not supposed to do that. And if people only turn left on weekends and at night, then it's probably just a rush hour enforcement. So there's actually some really cool things you can pull out from just looking at a single sensor, a single dimension of data. So at this point, I should probably talk about privacy because it's really crazy what we're able to do with this data, but it's really important that we do that responsibly. So this is an example of how we would handle looking at a single trip from a single device. So as I mentioned, we only are collecting timestamp, latitude, longitude, elevation, and then sort of some notion of accuracy of that data. So in addition to that, every time we see a trip that comes into our system, which again is anyone that's using Mapbox, hitting into Mapbox API or using our navigation SDK or something like that, the first thing we do is we connect all those probe points to create a profile. And then from there, we can derive things like speed and acceleration, deceleration for our traffic product. But we also take that and we cut that trip into segments, where each segment is no more than 5 minutes long. But that's also not good enough because then we would be able to figure out where you started from and where you ended. And we don't want people to make any inferences about where you live or where you work. So we also always cut off the very beginning of your trip and the very end of your trip, as well as a bunch of random other stuff. So as a result, we actually end up throwing away about 10 to 15% of all the data we collect. But that has actually repaid itself with interest because of a lot of the rising concerns around privacy of data. We've chopped up our data so much that not even we can figure out who you are, which is great. So we don't have to worry about like regulations such as GDPR, fortunately. Actually, we didn't have to change anything about the way we do business, which is awesome. So finally, getting to some of the meat of some of the cool stuff that we're working on today to add vision to this. Basically, we're just going from probes to, I don't know, super probes. So now we have not only location information, but we also have lots of information about what infrastructure looks like at these places. And this adds a huge degree of dimensionality to a lot of the live data that we pull in. So a lot of my background comes from a world more like this. A lot of the amazing work that's being done at Uber and Cruise with autonomous vehicles, where you probably have anywhere from 6 figures to 7 figures worth of equipment on a vehicle, and you can do some really incredible things with it. But one of the challenges about this is it's extremely expensive and is quite difficult to scale, and we've made a ton of progress. But one of the things we're trying to do at Mapbox is find more ways of leveraging sensors that are more prolific. So here, if we've got like a graph of coverage versus richness of data, obviously Mapbox, if we're talking about our GPS data, and we're working with GPS probes, which are some of the most plentiful data source or data types in the world, where we have extremely high coverage, 9 billion probes a day just for us, but not very good richness. We have to do some really clever things to get a lot of meaning out of those. And then sort of at the other end of the extreme, we have like LiDAR point clouds, where we're able to have really precise, within a couple centimeters, 3D models of entire cities, which is incredible. You could actually, this has a nice analog also to vehicle automation. We have level 2 vehicles where like a Tesla with autopilot can drive on almost any highway in the world. But if we're talking about a Waymo vehicle or a Cruise vehicle or an Uber vehicle, there's probably just a handful of cities where those would work well, and it requires a ton of infrastructure to maintain. So obviously the place we're trying to get to is how do we get richer data with greater coverage? So one of the stepping stones that we see at Mapbox to accomplishing this is with a Vision SDK. So what we've created here is a multi-platform solution that allows developers to build tools that incorporate vision and bring visual context to the navigation experience. So this is all real footage of driving in San Francisco, just running on my iPhone 7, put into a mock-up with an iPhone 10. But we're running augmented reality navigation. This is sign classification. We're doing object detection on vehicles, pedestrians, signs, signals, cyclists, and then finally semantic segmentation. We run all these at about 10 hertz or so. So just a quick review. These are like sort of the three building blocks that our developers have to work with. So we do classification of things like signs. We can do semantic segmentation to pull out things like lane markings, road boundaries, sidewalks. And we do object detection of really important things, especially things like vehicles and cyclists. This is also super easy to remember because it makes a haiku. So in terms of some of the customer-facing or use cases that we see like developers being able to build, there's a lot of cool stuff you can do with augmented reality, like visualizing pickup drop-off zones or where parking is available. There's a lot you can do with having more granular directions. So instead of telling a customer, like, make the next left, we can say, actually, you need to make a left lane change in the next quarter mile in order to make your left turn onto Bryant Street, which can be very helpful places like the Embarcadero. And we can also do a lot of the same functions that people find in the application ways today can actually be automated with computer vision. So if you have a community of people using an application, you can warn each other about things like emergency vehicles or road closures or construction, things of that nature. Thinking more on the safety side, definitely not the same type of safety you would find in an autonomous vehicle, but safety that can still save a lot of lives and be used in the fleet sense and also in retrofitting older vehicles. There's all sorts of cool stuff we can do around warning drivers about pedestrians that are in their path. There's also a lot we can do around detecting tailgating, speeding, running stop signs, things like that for fleet enforcement, also for insurance purposes. This is actually just one example. This is, again, driving on Market Street. So what we're showing here is a couple things running at the same time. So we're detecting the speed limit, and this particular lane is 10 miles an hour. So whenever I exceed that, which I do quite a lot, it shows up in red. And then we're also, we've turned our cyclist alert up to 11. So you can see that there's a cyclist right in front of me that I'm not going to hit. That's just like one example of just sort of prototyping a bit with some of the safety features. Our augmented reality team has also played around some with this. So this is actually taking driving data with the Vision SDK from a phone, then putting it back into our map environment to visualize where these vehicles show up. And then this one is showing how you can also arbitrarily pull in like POI data. So we have this vehicle in front of us that we're detecting, but we also are marking where this Muni stop is. So Vision SDK, I'm obviously talking a lot about phones. It's not because we want to build a map of the world with a bucket of iPhones. It's actually just a really great platform because it's got communications, GPS, a pretty powerful processor, and a great camera. But we're also interested in other ways of pulling this sort of experience into other things like maybe the vehicle you buy at a dealership. So this is actually from a video or a collaboration we did with Porsche back at the end of last year, just showing some of the cool ways that you can bring augmented reality navigation into an experience and like maybe let a friend know like, hey, I'm driving down the highway and it's gorgeous, and you just tap your steering wheel instead of pulling your phone out, something like that. So we're exploring a lot of different ways of bringing this functionality into the experience. So this is more on sort of the front end or facing the consumer. But on the back end, obviously, this just means really cool data also. So this is actually a short demonstration of basically what we're able to do while you're in the car driving down the road. You have this real-time segmentation information, sign detection. But obviously, as I'm driving, I also know where I am, and I know roughly where I'm looking. So changes to infrastructure that are observed by the Vision SDK can also be used to update the map, which is super neat. And what's exciting about this is not that we're doing machine learning, because everyone is doing machine learning. But what's exciting here is that we're able to run it on contemporary devices, of which there are billions today that can already run, which is great. So here's sort of an example of how this works in real time, or just, again, just using a phone. So this is just driving down Oak Street in San Francisco. You can see on the left here that red lollipop that shows up around the 25-mile-an-hour speed limit sign. What's neat here is that we don't have to record. We don't have to send any imagery back. All we have to do is be able to detect a feature of interest. And then instead of having to upload any imagery or video, we can actually send just sort of this little JSON snippet. So like with 72 bytes, we can actually send what that was and where it was and the time that we saw it with our production telemetry pipeline. So we've actually already implemented this. So if we recall back to earlier, talking about probe data, so now we have probe data that looks like this, but now we can arbitrarily append it with other pieces of infrastructure information. So that same probe point now can come with more information about construction or road closure or an incident Or if you just want to pull in other types of information, we have a whole bunch of different options that developers have to work with. And what this starts to look like at scale is we're able to pull in all sorts of pieces about infrastructure. So here we just drove for a while in, looks like, I think this is Denver actually. So we're pulling in stop signs, parking restrictions, other regulatory and warning signage. But this is totally arbitrary. Like we could just as easily pull in like more ephemeral things like construction or backups. And there's quite a lot more you can discern from there's quite a lot more you can discern from being able to interpret an image on the edge than have to wait for 30 or 40 vehicles in terms of probe data to show up. So this is a pretty cool thing. So in terms of what does this mean for the developer community, obviously this is something we want everyone to be able to play with. So this is well timed. Fortunately, we're about to go into our public beta. I'm going to say next month, probably. And I'll get back to you guys on that. Seriously, probably next month. And any developer in the world with a Mapbox.com account, which is free, will be able to build on iOS, on Android, and we'll also have Linux SDK coming down the road. So that's it. Thank you.